This is in, I think this was in 2019. And she said, okay, where would you like to go? And I said, well, I would like to go everywhere because I love to travel and see different places. She said, okay, that's what we can do. Our plan is to travel to different places and teach them this programming. In that spirit, I recruited Rylan and also promised him to travel all around the world. And yet, here we are on Zoom still for like, what is it? It's almost a year and a half now. But I think, you know, there are some obstacles with the Zoom, but there are also some strengths, I think. Most likely, it would have been very hard for us to travel around between the 4 or 5 different locations where you all are right now. And so I think that there are some real advantages, and we want to try to take advantage of those abilities that we get through Earth Engine. So what we are going to do for the next couple of minutes is orient you to what we're going to teach. Then we're going to tell you about our lab and how we use Earth Engine. Then we're going to start doing it. That's the goal. And I'll give you some specific objectives here in just a minute. So Rylan, let's go to the second slide. Okay, so yeah, if you go, why don't you go back one just for a second? So if you have any questions about how to navigate Zoom, you can just go back to this first page. How can you get to this first page? If you see at the top, you can just type bit/ly, and we'll type that in here. Rylan already continually is ahead of me with everything I've prepared to ask is already there. That's great. You should just be able to click there. That will allow you to see the exact slides that we're talking about right now, both now and in the future. So these slides are always going to be here for you. If you want to raise your hand, you can see down at the bottom, there's some way to do that. You could change your name if you want to. You can either mute yourself or we can mute you if by accident, you know, you leave the microphone on, which I do all the time. And that's what we'll do. All right, so let's go to the next slide there, Rylan. So we are now in part 1 and part 2. I'm going to give you the learning objectives and the logistics for what we're going to do. Then we'll tell you who we are. Then for the 4th part, we're going to tell you what is Google Earth Engine and what are the abilities that it gives that are unique. We'll take a short break at that point. If you want to stand up for 5 minutes and visit the restroom and come back, I think you can do that no problem at all between now and part 5, if that is okay. When we start part 5, you will need to follow along, or at least that will be it'll pay off the most if you follow along at that specific spot, and that's part 5. We will do this Earth Engine 101 training. You can see, I'll mention again as we get there, that the document is both in English and in Spanish. And if anyone is tempted to translate it into other languages, I think that would also be a pretty neat thing. It's only been in Spanish for about a month because one of my graduate students decided she wanted to have it be in Spanish, so she did it. We could talk about that if that would be interesting to you. Then to finish off today, you will continue Earth Engine 101 on your own. We'll still be here, but to allow people to kind of move at their own pace from there. Then on the second day, what we will do is to try to prepare you as much as possible for being able to use Noel's time well when he's feeling good and can meet with him. I think of this as really a pretty useful kind of first and second stage. We'll give you the basics and he'll give you the specifics. He will work with you for your own specifics. In order to be able to use the tools that he will show you and talk about, it will really help if we can bring you up to the level of experience that can really benefit from having like an extreme expert involved. So let's go now on from this slide and ask you to make sure that you have signed up at earthengine.google.com. If you have not done that, you have to do it in order to do part 5. So you need to do it by clicking on sign up, and then sometimes the email goes into spam, as that happens sometimes, into a junk mailbox. So now let's go to the next slide after that. So the logistics is that we will refer occasionally to, okay, let's go back to the home slide, or let's go back to the beginning slides. That's slide 3 on this page. That was the one that had the outline of what we'll cover. What we will do is we'll follow that order pretty closely, and also we'll be available to help in a breakout room throughout the workshop, and I'll explain that just a little bit more in a minute or two. Okay, so let's go to the next slide. So to tell you who we are, we will give you an overview of our lab's work at McGill University. So that's where I am, and I do research. Almost all of that research now is with Earth Engine. And so it is pretty much revolutionized the way that I do all of my research. I think just about everything that I do involves Earth Engine now at some point or the other. Okay, let's see if we can go forward from there, Rylan. I imagine you're trying to do that. And bring us to slide number 7. So if we go to slide 7, which I think there are numbers, page numbers down in the bottom. No, I'm sorry. Let's go back to the main slides. Yeah, there we go. That's slide 7. Perfect. So who takes these workshops? So different people have taught this workshop probably hundreds of times. I have taught it on Zoom now, I think maybe 5 times. So what we'll show you is things that we have evolved over time based on the basis of Earth Engine 101. So who are the people who take these workshops? This is from a different pre-workshop survey, but when I looked pretty quickly at what Paul had sent to me over the weekend, it kind of looks like this group. We have a lot of familiarity with GIS. I heard during the introductions that there are quite a few people who do GIS as their job. I think that this will be a really relevant and useful workshop for you. And yet, for many people, the familiarity and comfort with computer programming is low, generally. There are some who have like maybe a 4 or a 5 out of 5 experience for programming. Most people, I assume, will not have that. And so that's what we are trying, that's like real specifically what I am trying to build. And also that the existing knowledge of Earth Engine is pretty low for this workshop. And so where are you, at least from the stuff that I got, and I think this fits pretty well with what we heard today. There's a mix, and we have at least 5 different places located. So let's go to the next slide after that. And now I want to try to practice the chat, all right, as we get into the part where I'm going to ask you to do some things. So please, if you would, type "help, I am lost" in the chat, if you would be willing to do that, just for 2 seconds. I like that, "help, I am lost." That's funny too. So this is fun. I've never done this before. This is just improvised. But this is what we want you to do when you get lost, all right? So you just type that right in the chat and we will get you straightened out. The idea is, like, if we were all in the same room, you would put up your hand if you got stuck. Save me, I'm lost. You would put up your hand and you would say, "help, I'm lost." We would walk over to you. We would then, you know, whoever it was who was helping would say, "oh no, you need to type this thing and that thing." And so we have a way to simulate that, and that is for you to type this, to type as Chris did, "please save me, I am lost." And so that's what we want to ask you to do. We'll now go to the next slide and ask you to type another thing, just real quickly. Type in your name and where you are, how many other people you know in this class, something you'd like to do, and the temperature where you are now. Because if I understand right, it's warmer where you are than where we are. So just for a minute, I want you to just be familiar with the chat and to be comfortable and confident to use it, even when you're lost. All right, that's great. I see several people typing. I don't see anything popping in yet, but it's going to come in a minute, I suppose. So that's great. And so I'm asking about the temperature really because it is quite warm in Montreal right now. We don't have air conditioning in my house. Oh, 37. Oh my goodness. Okay. It's 29 here. I thought that was going to be impressive, but 37 is, that's serious. 27, 22, a big range. Great. Okay, so let's go to the next slide there, Rylan. And these are our objectives. This is what we want you to be able to do. We want you to get confidence using the Earth Engine JavaScript API. Some of you will not know what those words mean to begin. JavaScript, you maybe have no experience. API, you might not know what that stands for. By the end, you will know what those terms mean and you'll know how to use it. You will learn how to create and also how to customize scripts. That's a big part of programming. We want to connect you with each other as well. And we want you especially to learn about additional resources and where to access them. Everything that we show you is online. It's not as easy to learn by just reading stuff off of the screen, and that's why we're doing this training with you. But the ability to do next steps is there waiting for you. And so if you are inspired, as you see here, to make your own scripts and tools when you're done, we want you to know how do you get started and where do you go to do that. So that is part of what we'll do on the second day, which again is Wednesday. So for me, I will mention that I know 3 or 4 people here in the class, and I like baseball. And in fact, that's why we're not going to have the class on Tuesday, because I coach my son's baseball team. And so we have a game tomorrow night. And so I won't be able to do this on Tuesday, but so we'll do it on Wednesday when I have my own softball game, but that's later on after this. All right, so let's go to the next slide there, Rylan. We want you to learn how to do these specific things as well, not just the concepts. But we want you to know how to make a cloud-free mosaic with Landsat 8 images. Given where you are located, that might be very hard, but we're going to try to at least make the basic calls on how to do a cloud-free mosaic. We will create training data with Earth Engine to train a model. We will train and run a classification and regression tree model to create a land cover map. You will learn how to customize a script, how to edit a script, a little bit of how to copy and paste the script, and then also, as we say there, inspire you. All right, let's do the next slide. So for the hands-on part of the workshop, you can, as we say, come and go as you want to. But it does, the idea is we're going to at some point have some stuff in my mind on the left side of your screen, and on the right side of your screen, we're going to copy from the left side to the right side. If you're fortunate enough to have 2 monitors, this will be a way that it pays off. I'm going to do it in 1 monitor for myself over here, but everything's squeezed onto 1 monitor to show you how we can do that. But again, importantly, most of the sections in Earth Engine 101 that you will see, there is a link to a script at the end. So if you don't want to paste, or if you get lost, or if you just want to see what happens if you plug in the script, you can do that, and we will show where that is. And Rylan, if I forget to show that link to the script at the bottom, just remind me to jump down there and show it to people. All right, so let's go to the next part, which is the preview of what we're going to do in Earth Engine 101. Okay, we will teach you about JavaScript. That is a programming language that you will learn pretty well, at least as a beginner, by the end of this time. As I say, I love doing this, and so it's really it's an honor to get to do it, honestly. So we will then also teach you how to find imagery in Earth Engine, and then how to display it, how to do some calculations and computations with it. You see maybe where it says GT, we'll explain what that means. You'll know how to do that. You will know how to do the slope command, reduce regions filtering by date, that will be in the second half of what we'll do. And then how to do these different types of mosaicing, and hopefully that will make perfect sense by the time we're done. We might touch a little bit on exporting and charting at the very end. Okay, let's go to the next slide. Then on the second day, we will do a classification of multiple dates of imagery. And we, when I say we, I mean you, either individually or as a group, as a small group, you will create a very, very rough land cover classification for some area with data that you train, data that you input in a very rough way. But the idea here is that by the end of doing this part that's on the page here, you will have the basic knowledge that you can then employ to have really fruitful discussions with Noel, or if they let me do it, with Noel and me when that time comes. Okay, let's go to the next slide. Let's wait on the photo until Wednesday, Rylan. Let's now at this point go back to the home slide. All right, and now we will go to the who are we? So where we get to there, Rylan, you bring that up. That's part 3. And we will tell you 8 slides about this. And then we will start in on some other stuff. So I'll just introduce it very briefly to say that this is just an overview of the research within our lab at Mcgill. The work that you'll see, Rylan will describe his stuff in the most detail. And the work from other students of mine are Africa Flores Anderson, who is a PhD student, Rylan as well, a PhD student, Morgan Crowley, also a PhD student, Eli Perez, who is a master's student, and Talia Cole Edged, who I just approved her master's student about 10 minutes before this started. So for right now, she's my student, but soon she will be allowed to move on and do her own work with whales that she's looking forward to. All right, let's go to the next slide, and I think that comes right to you, Ryan. Yeah, skip this one. Let's go to the next thing. Go for it.
Sure. All right. Hello, everyone. Nice to meet you all. I'm Rylan. As Jeff said, I'm a PhD student in his lab, and I'm a computer scientist by training, and so most of my work focuses on using deep learning to create land cover maps, and in particular, I'm interested in historical maps of forest disturbances. So we're interested in this because the earlier we can create a baseline map for, the more complete picture of change we can get. And then there are some significant challenges with using this early data. In particular, there's less of it from the first decade of data. It has worse spatial resolution. There's fewer bands. The measurements are less precise. And so creating maps of the same quality today is a lot easier than it was in the 70s. And so to overcome these challenges, I use deep learning, which is a family of machine learning algorithms. The primary differences between deep learning and more traditional methods of creating these land cover maps for our purposes are that there's a spatial component to the deep learning. So the values in the neighborhood of pixels contribute to the classification that you make for one pixel. And also these models are significantly more complex. And so this complexity means that you need a lot more labeled training data in order to create a model, and that it's hard to interpret a model. So unlike with a random forest where you can open it up and say, how did we make these classifications? That doesn't really exist for deep learning. So there's benefits and drawbacks to it. The reason I use Google Earth Engine for my work is because it provides access to all of the data that I need incredibly easily, and it also works well with TensorFlow because they're both made by Google, and TensorFlow is the deep learning framework that I use for my research. I'll pass back to Jeff.
Okay, great. So one of the things that you will notice tomorrow is that it becomes, with Earth Engine, very easy to make classifications. To create them soon for you tomorrow will be sort of like pushing a button. you'll push the button with programming, and then I guess actually push a button. But we end up with a lot of classifications which can be pretty rough. And we have many sensors that are possible. Rylan mentioned the MSS sensor, which goes all the way back to the 1970s. If you've ever looked at that data, it is pretty difficult. There are a lot of stripes in it. It's sometimes misregistered, where it's just in completely the wrong place or slightly the wrong place. It can be very cloudy as well when we look back, and there's not much data that is clear as we move back, especially in cloudy areas. And we've got, looking in the future, more and more satellites that will be launched that are available for us to use. And so in Earth Engine, what I do for my research is try to create algorithms that can use multiple satellite platforms interchangeably, so that we can kind of harvest the information from satellite images, regardless of what type of imagery they're from, or when they were launched, or what the purposes were for them to have been launched. So I try to use sort of information theory strategies to pull information from piles and piles of data. So Earth Engine is a perfect opportunity for that. Okay, let's go to the next one. And I think that this one after that slide should show kind of the good and bad of satellite imagery. This is a place in Brazil. It's the Roosevelt River, which is quite cloudy, as you'll see in many of these images. These were the clearest images we could find for that particular period. And what our algorithm in our lab does is it takes images that are on the left and turns them into these rough classifications, like I mentioned, in the middle. Those have, kind of, you can see some clouds as they go by. You can see sometimes they don't cover the whole area. You can see sometimes they're exceptionally clear. Maybe it was a great clear day. But it also uses 7 or 8 or maybe 10, I guess 10, different types of satellite data being seen on the left and then mapped in the middle. What my own algorithm does then is the thing that's on the right. It takes the messy classifications that are shown in the middle and says, well, I should be able to figure out something from these. If something is noisy, it's probably not noise every time in the same place. So maybe we can watch to make sure that if it's said again and again, then we should update the land cover. So you should be able to see in the middle, you see some black areas. Those are no data. Red areas are considered as having been recently deforested or used for agriculture in some way. And so when there are noisy images, they tend to then have the next image be pretty good. And so what my algorithm does by interpreting things to the third stage is to sift through those noisy images and make what turn out to be very clean classifications. And this, in fact, uses a particular technology that Noel said was written for my group. It uses the iterate command, which is something that's in the application programming interface, which you will then learn about next. All right, I think that is maybe the last slide for here. Let's click one more ahead there, Rylan, and then we will go back. Yes, now we will go all the way back to the top slide, and we will try to explain what we mean when we say, what is Google Earth Engine? We'll go through these slides, I think, pretty quickly. Even though we're not actually in a rush compared to the calendar that I have here, the schedule that I've got. So we have about 20 or so minutes, Rylan, to go through this, and then that puts us right on target. All right. So let's see. Let's go from here to the next slide, which says, what is Google's mission statement? So Google's mission statement, you may know the legend of it being founded by 2 graduate students who wanted to try to organize the world's information and make it universally accessible and useful. At that time, Their main goal was to gather up the text information that was on the internet and try to make it accessible and useful. Now, of course, they branched out into all sorts of technologies. Now we have Gmail, now we have Google Maps, now we have Google Earth, and here what you're here to learn about today is Google Earth Engine, as well as like 20 other things that they also have. But those are that's the kind of stuff that is the bigger definition of what they mean by world's information. And that's what you're going to learn to manipulate with their tool, Earth Engine. Okay, let's go to the next slide. I mentioned that there are a lot of satellites. The ones that are on here, I think I've used like 3 of them, maybe. One in the middle says Landsat 7, another one says EO1, another one says Terra. Those are ones that I have used, but the others that are here, I have not really used. It's that big of a world. I've been doing remote sensing, for like 15 or 20 years, I guess. And yet there are still many, many untapped technologies. One big reason why I haven't used these other data sets is because it's very disorganized about how to go get data. And until Earth Engine, data was in each particular place. So Landsat 7 had a place that we went to go get the imagery. Landsat 8 had a place that we would go to. Terra was in a different place. You then had to download a tool and then project the data, and it just kind of took forever to do relative to what we can do now. These others had interfaces for downloading the data that I couldn't even get into, and so we just let it go and did other projects. Now we have the ability to access all of the images for all of these sensors anytime we want. All right, Ryan, let's go to the next slide. So they have lots and lots of imagery. There is at least 50 some petabytes of Earth observation data. It includes not just imagery, but weather data. There's temperature information, there's wind information. I've used a couple of those, but mostly just imagery, and that's what we'll focus on now. All right, let's go to the next. One thing to know is that this runs on Google's computational infrastructure. So it's a great tool for running when you have low bandwidth, relatively low bandwidth, because you can basically do supercomputer maneuvers using their computers. And so when you signed up for Earth Engine, that's what they are giving to you. That's what they're giving to us, is a key to be able to use this or some other gigantic room of computers that are all wired together and give us answers back. I'll try to point out when that is, what that looks like when we do the tutorial. All right, let's go to the next. There is a powerful API. This stands for Application Programming Interface. And what that means is that we are able to write programs that then are issued or that then are sent somehow to Google, which then are processed somehow into computer logic and sent again somehow to their computers. Noel would know all of these answers, but it's not really relevant for us. The way that I think of it is I have a supercomputer and I can run it on my laptop. So let's go now to the next slide. One of the first things that they did with Earth Engine, once they downloaded or ingested all of the imagery from the USGS, the US Geological Survey, was to use it to create a cloud-free image, a cloud-free composite across all of the Earth. This area in Borneo is basically never clear. It's always got some clouds over it. But when they did a particular maneuver, which you will learn about and you'll be able to do, it's shown on the slide after this one, I guess. Go ahead and hit it, hit the go. What you will do today is you can think of it as, I'm going to take all of the Landsat images or all of the satellite images. Then for every pixel, I'm going to pass a pointer down through it, and I'm going to look for the best pixel, maybe the greenest pixel. maybe a dark pixel, maybe the one that is rated as having no clouds in it. Then I'm going to take that 1 pixel, maybe I would take 4 pixels and then blend them together, perhaps. And then I will make a map of that output. And that's what this does. If you go to the next slide, it shows the clouds again. And then after it, it then shows what it looks like after the clouds are removed. And I would say removed is sort of the word, but the idea really is when we have an enormous stack and we take the 1 pixel that we want every single time across the entire space. You can see they also afterwards, they cleaned it up a little bit. And this mosaic looks cleaner than the mosaics that you will make, almost definitely. Especially if you go over a very cloudy area. It doesn't look like this right away. My understanding is that they then did some smoothing of the images so that it didn't look, so that it looked smooth. You can see that in the water on the southeast coast, you can see some stripes that were left there to remind us that there was some smoothing done on the land. Those stripes, if you have ever looked at Landsat 7 data, you might know that the Landsat 7 satellite was launched in 1999, and then in 2002, it broke. And it broke in a way that looks like this. There are stripes on every image that are about 20% of the stripes, or 20% of the image is just black, entirely gone. But you could imagine if we take an image from last week or 2 weeks ago and put it in its place into that area where it's a line or a strip, it would be better than nothing. But it wouldn't be perfect because there are always differences between images on different days. And that stripe, we're able to do with our brains very quickly to see that something isn't natural or right with the water. And so that sort of cleaning is also done on mosaics. All right, let's go to the next slide, Rylan. So there are many years of imagery. This number almost definitely is pretty old now. I think we've got 40 some years of imagery in our studies as well. There are millions and millions of scenes, quadrillions of pixels, and you can run an analysis that has 1 billion pixels in it if you want to using Earth Engine. And we'll give you the tools to do that as part of this workshop. All right, let's go to the next slide. And now if I could pass to you, Rylan, that would be good. Can you do some of those?
Yeah. So as Jeff has mentioned, one of the huge strengths and benefits to using Google Earth Engine is that it provides access to almost all of the data that you could possibly want in an incredibly easy fashion. And so for this workshop in particular, we're going to use, I think, just Landsat 8, but it provides access to all of these other sources of data. So there are daily MODIS composites, which provides an image of everywhere on the Earth every day, but at really low spatial resolution. There's terrain data if you need access to elevation or slope. There's atmospheric data. There's Sentinel-1, which is synthetic aperture radar, which has the ability to see through clouds. And if Africa, who's another PhD student in Jeff's lab, were here, she's a SAR expert. If she were here, she would have a lot more to say about this than me. And then, of course, there's Landsat. And so there's 40 years, this kind of historical record of everywhere on the Earth, which is more my area of expertise. And of course, when you get 40 years worth of data, you can create these essentially movies of watching the land cover change over time. So there's a Google Earth Engine application called Time-Lapse, which I'll send a link to, where you can go and zoom in anywhere in the world, and it plays an image, 1 per year, and shows how land cover has changed over time. So this is an example of a river, I believe, in Brazil, not 100% sure. And we're looking at urbanization changes. It's the same time-lapse application. You can see the date changing in the top left corner. And then deforestation. So this is the link. I will just copy this so that everyone can go look, maybe go find a place on Earth where you've been and and you can see how satellite images show it changing through time. And now I'll give an API preview. So Google Earth Engine is programming, which means that the way that you interact with it is through writing code using this application programming interface rather than clicking and dragging like you would in something like ArcGIS. So there are 4 kind of fundamental data structures in Google Earth Engine. There are images, which is what we know and think of as images. They have bands. These are raster data, bands and pixels, and then a bunch of metadata associated with that image. And then because we're generally interested in looking at large areas or through time, we have image collections, which is just a stack of images, either through time or space. And the API provides a bunch of ways to interact with this. So we can apply the same function to every single image in the collection super easily. We can filter out images that we don't want. We can merge them like Jeff showed earlier to get rid of clouds. And then when we're interacting with these images, we can do band math to calculate spectral indices like NDVI. We can clip images to regions. We can calculate the gradient. So if you have like a terrain raster, you can take the gradient and get your slopes out of that. And then the other fundamental data structures are features or feature collections. And this is kind of oddly named if you come from a ArcGIS background. And so things that you would think of as vectors in ArcGIS are called features in Earth Engine. And so a feature is just a geometry, like a polygon or a point on the map, and then a bunch of metadata associated with that point. And then again, like with images, we have feature collections where we have a bunch of these features combined together in some way. And so for the features, we can operate on them by buffering out their size. So if you have a polygon and you want to get the region outside of it, you can buffer it out. We can do all sorts of geometry, intersection, union, stuff like that, finding the centroid. And all of this stuff, some of this stuff will be covered in more detail. This is just kind of an idea of what you can do. And then with the feature collections, same idea. We can apply the same transformation to each feature in the collection. We can filter out features that we don't want based on their metadata. We can sort them based on their metadata and things like that. And then Earth Engine also provides direct access to some basic machine learning. So what I do with TensorFlow involves some kind of tricky integration with other stuff, but built directly into Earth Engine is access to random forests and support vector machines and classification and regression trees and other models of that type. The other thing that Earth Engine allows you to do besides just kind of creating maps and exporting maps is creating interactive applications. So if your work involves creating kind of forward-facing things that you share with the public, Earth Engine provides some powerful tools to create that. So again, this is an example of time-lapse, but looking at water cover around the world. So this is an example of what the interfaces look like that you can create. So this is measuring evapotranspiration across the United States, and you would write the code in the background and then create this application that is out there online and then allows people who are not programming experts to go and interact with this by clicking and dragging and drop-down menus, things like that. It's just another example of what that looks like. You can create graphs and things like that. And then this is time lapse, which I already talked about. And yeah, we'll now go back to the beginning, and I believe this is our time for our break, but I'll pass back to Jeff.
Okay, perfect. So what I will do is now I'm going to share my screen. Why don't you stop there, Rylan, and then I'll get ready to share mine, which is what I will recommend for you to make your screen look like. As Rylan said, we're going to take a break for about 10 minutes. So right now for me, it is 6:30. So we're going to stop at 30 and we will resume at 40. Okay, 40 minutes after the hour. So I really love this time lapse thing. And so I want to show it to you. It's sort of Earth Engine, but it's sort of not. But I see it as an extremely powerful capability that they were able to program after they ingested all of the imagery. So here, this says drawing of the Aral Sea. Here, I'll make it a little bit larger. And you can see that you can go anywhere in the world. If you click on mining, it will then go here to Alberta, Canada. Not at all near where I'm from, even though we're from Canada. This is like 3 days of driving away, I think, in Canada. And so this is some mining that happened there. If I type Solomon Islands, you will see that this is basically what's happening is this is a movie that is always running around the Earth. And what we are doing is accessing the movie. The movie has one frame for every year. You can see at the bottom, it's going up to 2000, 2010, it's almost to 2020. Now it goes back to 1984. That's when Landsat 5 was launched. That's the period just after the kind of initiation decade of satellites that Rylan is studying. So as it goes through, you can now see these stripes, right? So if you may have wondered what the stripes were at some point in the past, that's what the stripes, these are those stripes, and this is what they look like. So here, this is just, I don't know exactly where it zoomed to in the Solomon Islands, but perhaps this looks familiar to some of you in this spot. The idea of what it does is it takes, similar to what I was trying to show when I said, here's a stack of images, I want the best one out of there. They took one best one for the each year, and I think, unless my screen has totally jammed, should be able to show that. So it's kind of strange. I haven't seen that too often, but type somewhere else and see if it will maybe want to restart. But maybe I'll just consider that as a good sign that it's time to move on. I've got just about 6:30, so I want to finish by showing you what I would like your screen to look like in order to be able to do the next part the best. All right, so I'm going to go and split my screen into two parts. The first is I'm going to go to part 5 where it says Earth Engine 101. How do we get here? We go back to the home page. You should be able to get to this page on your own by now. If not, you go to the chat and look for where it says EE-Mcgill-Silver Carbon. That was at about, well, I don't remember what time it was precisely, but you should be able to see it there. You click there, and that will bring you to this set of pages. I think it brings you to this third page. You then look for where it says part 5, and you click Documents, and you click in that. Let me ask you that when you can successfully do that, that you type OK in the chat. If you cannot do it, I guess, yeah, let's type help, I am lost, please save me, and we will help you to get to that spot, all right? Once you are at that spot, that's for the left half. On the right half, you go to code.earthengine.google.com, which if it's not already in the chat, we'll put that in the chat. And when you do, you will get something that looks like this. A bunch of scripts, except if most likely this is blank or small for you. This is the scripts within my lab that we are working on. There's a million of them. But the main part of what you'll see is over here where it says new script. You also should look for this slider here. Sometimes, if you notice, if I move it to the side, it sort of disappears. Okay, if you come here and you say, wait a second, I only have 2 panels, what's going on? Then you go over to the right and you grab it and then you see it. We're gonna need both this panel and the panel to the right when we reconvene at 6:40. So let me urge you to either write okay or I'm stuck so that you're ready to go when we come back at 6:40 or at X40 in about 7 minutes from now. All right, thanks very much, and we'll talk to you soon. All right. Hey, Paul, do you think you could maybe help Eper get reoriented in the next couple minutes?
I can try, yeah.
Okay. Okay, issue with accessibility of Google Docs. Does that mean everywhere in the Solomon Islands? Or does that mean this particular group?
What,
Want to know the answer to that.
Chris, can you clarify, please?
Well, what I'm going to do is I'm going to try something new that we never did before, which is I will download this whole document. It's not so big, but it's now pasted into the chat. So you should be able to open this and look at it, and it should look the same. It doesn't have to be online really, that part. Okay, so see if you can get there for that part. All right, so I'm gonna stand up for a minute if you guys don't mind, and I'll come back in a sec. All right.
Eugene, are you there? Can you hear me?
I'm here.
Okay, what is happening?
Well, I'm just trying to get to know how you guys divide the screen. I mean,
You're, I didn't follow that. You're trying to get to the code editor screen, or?
yeah. How you I mean that. How do you make the 2 screen on your laptop?
Can you share your screen and show us?
Oh, I'll put. Oh, it says the host disabled participant screen sharing.
To get the 2 windows open at the same time on your laptop,
No.
you should be able to drag one to the left side, and then it will fill half the screen, and then drag the other to the right side, and it will fill the remaining half of the screen.
Oh, okay. I'll try that.
Also, yeah, also the keyboard shortcut was just sent in the chat by someone else.
Maka, can you hear me? You're on mute. I had a question for you. We had someone. There was one person trying to join who they were asking for a code for the Zoom meeting, and there shouldn't be a code. And I was wondering if when you were trying to join, did it ask you for a code? I think there's just one person having trouble. Didn't ask for a code.
Yeah.
Yeah, I did same. I didn't set up the meeting, but I didn't. As far as I know, no one else had to enter a code. Okay, I'll email the person back. Thank you.
Okay, hi everyone. Welcome back. Let's get started. So let me ask you to type in the chat, ready. Once you are ready, we'll make sure that I'm not starting too abruptly here, just to make sure people are back and around. Okay, why don't we get started? I see quite a few now. That's great. So let's make sure that we can get to the Earth Engine site. And what happens when you click on section 00, it says go to the Earth Engine site. So I want you to sort of move down to this lower part of the document. I don't know if it has page numbers on it, but maybe I should put some page numbers on it. But anyway, you can see section 00, go to the Earth Engine site. That's what we have over on the right, okay? So now it says this: open up the Earth Engine JavaScript code editor and type or paste the following text. So for me, I will copy it. So I'm going to do, Control C, move it over here, and see whether it will say hello world. Perfect. So it is ready to be run now that I've moved it over there or copied it into that space. And if I click run in this spot, it will do that action that I request. So if you have that successfully set up, then you are ready to go and to move faster. So if you could type yes into the chat just for a quick moment. And then we will know that people are sort of tuned in and good. Great. Okay, so that's great. So if you haven't done a lot of programming before, I will explain what this is doing and some of the different parts of what is happening. In order to do that, I will make the print larger. I think I can probably do that. There. When I make the print larger, I notice that one of these panels went away. That's okay. I don't really need a list of the scripts, but I did want to have the console. Great. So now you can probably see in my bit or in yours, you can see print, then a parenthesis, then a quote, then a letter H, then ELLO and all the other things, then another quote, then a parenthesis, then a semicolon. So what is happening here? What is happening here is that we are issuing a command to the interpreter. This is JavaScript is an interpreted language. We're issuing a command to the thing that is waiting for input that's, I think of as sitting here and waiting for me to say run. It then says, print, have I ever heard of that before? Yes, I've heard of that before. What does that mean? It means that I need to for sure have a parenthesis next. Then there are different things that might be printed inside. Then I have to remember to close the parenthesis, and I have to, should remember to put the semicolon at the end. If we make a mistake, this is what it looks like. Remember I said it needs to have a parenthesis. In this case, several things happen if I forget to have that there. I get a little helper that was written by Google for us when they were writing the interpreter. And it says something that's a little strange, but it does show me that something's wrong. It says, I got this semicolon too soon. It isn't a finished sentence, really. So it says something is wrong. So I'll put it back, and let's see what it says. If I take that one and remove it, it says the same type of thing, gives an error. If I forget to do the semicolon, it just gives a little warning and says, you might want to put that there. That's part of the language, not super important, but that's part of it. And so we could say, instead of hello world, we can write hello class. And if we do that, then we can say run, and then it says hello class. Now what we'll do is begin to think about variables. Variables are a way that we store objects in Earth Engine or in any language. What I think of it as is a box. I have a box with some things in it. In this case, the box is going to be called the answer, and the box accepts numbers, and the box will have the number 42 in it. So I will do that. So I will paste it over here and say var, which is required when you make a new variable. And what I'm saying in line 3 here is, I want you to make me a box. I want it to be called the answer, and I'm going to put the number 42 into that box. And then when I say run, it looks the same as it looked before, but the answer is available now inside the interpreter. So I could print that. Let's see if we can do that. We're going to say print the underscore answer. If we say there and we say run, there you can see it writes the number 42 to the screen. So if you have the space to be doing all of these things and also answer my requests, if you could type OK in the chat, if you're able to do that, that would be great. And it's especially hard at the beginning to get all the pieces moving because you're listening to me, you're maybe viewing something also. You have one window open and another window open. So let me see if you can get the number 42 printed into the console over here on the right. That is what we're trying to do. Okay, so if you are lost or stuck, now's the time, because otherwise you're just going to be lost probably for a long time. So if this isn't working yet for you, tell us right away so that we can then get you back on track. So really put up your hand in a way, and we will come and help you with that. Okay, so what I will do is continue onward now and come over here and say, this is a variable, it's a box with one number in it. Now let's see if we can make a variable called, in this case, my variable. It could be called anything. And now I'll move down a little bit by hitting the return. I say var my variable is called I am a string. Let me see if I can do that. Print parentheses my variable. So I do that, and if I hit run, it's going to say, I've never heard of a thing called my variable. That's a programming error on my part. So I look at it and I think, but I called it my variable. Then turn on a very precise part of our brain and look to say my underline. The underline is missing. I will put that in here, and let's try to run it again and see if it can get fixed. There, it runs now, and it can now write the words I am a string onto the screen. Okay, now what I want to do is move down a little lower down here to where it says square brackets. All right, so hopefully you can see this part, square brackets. I think I'm going to try to put page numbers right onto this document right now. I just put page numbers, I think, onto this document. Can you, if you see some page numbers appearing on the document, please let me know. I'm curious whether that would show up right away for you. But anyway, what we're going to do now is to make a list. A list in this particular programming language is made, hey, great, thanks, Lisha, is made with a square bracket. You remember I made a big point about the parenthesis, the curved parenthesis for taking a parameter for a command called print. Now I'm going to make something called my list and try to print that out to the screen. All right, so I'm going to bring it over here, and I will do that. I will do run, and let's see what they were asking us to do here. Here it says, I'm making a list that contains 3 items, eggplant, apple, and wheat. A list is an ordered set of items. Here, we ask for the first item. The first item in this particular programming language, JavaScript, is numbered as 0. I don't really know why, but that's how some languages work, where the first item is called 1. Some languages work where the first item is called 0. And that's just how it works. So if I want to get apple, I would then say 1 and try to get that onto the screen. So why don't you, for a second, see if you can figure out how to get wheat onto the screen. If you can do that, write yes, or write wheat or something like that into the chat so that we can know that we are heading in a good direction here. Perfect. Okay, so at least several people got that in there. If you don't, please tell us. We don't want you to get lost. Or in fact, we actually want you to get lost, and then we want to help you get unlost. So one thing that is good and fun in programming is making mistakes, but nobody gets hurt. It's just like a intellectual mistake, and then we fix the mistake, and then we can move on. It's actually a really liberating feeling to make mistakes with the computer for me. So as many of you said or saw, yes, in order to get wheat, we say my list sub 2. Now the word sub is maybe that's just an English or an American colloquialism, but I say my list sub 2, that's the way I was taught. And now we can start to see that there are different things, are different colors in this interpreter. String items are shown in red. You can see here's a string here, here's a string up here. I bet if I forget the first one, I bet it isn't colored red anymore because it's sort of a broken object. If I put it back in, it turns into red, the errors go away. Then the commands that are built-in commands in the JavaScript language are shown in purple. You can see print, P-R-I-N-T, is shown on the screen here. Now, my underscore list is shown in black. It's not it's not a string. Sorry, strings are in red. It is not a number like the number 42 here and the number 2. Those are shown in blue by the interpreter that Google wrote for us. It is just in black. It's regular text, my underscore list. So let's now look at a third type, which is great job, Trina, excellent. Now we're going to look at curly braces. This is the third, I don't know what that's called, a delimiter maybe? The third delimiter, that is for a dictionary. A dictionary is an unordered list of items. The items have a very specific structure. The structure is a tag and a value. This kind of idea of a tag and a value is what underlays everything on the internet. With HTML, it's set up like that. There's a thing and a value. That's what we have over here in this dictionary. Here for this dictionary, we have 3 parts. One is food, another one is color component, and the third is a number component. And I'm hitting return just to show that you can move things around a little bit on the screen if you want to, and you get that. Now I would like to, suppose I wanted to get the word red on the screen. I want my dictionary. It's not really a list. I don't know what happens if I ask for the second one, but I know the way that it's designed to be referred to is to say my dictionary, then a period, then the word color component. That is what I want to try to print to the screen. So I'm going to enclose that in parentheses here. Whoop, I'm going to try to make it look just like line 4. P-R-I-N-T. Whoop, now I will hit return, or I'll hit run. But in case you want to not be moving your mouse all the time to hit run, you can hit Control Enter. And so I might do that and forget, but I also want you to see me moving to hit run. And that is how we can get the word red onto the screen. Okay, so why don't you see if you can get red onto the screen? And that would be through like what's here, print my dictionary.color component. Let's see if you can get that as well onto the screen. Looking down a little bit, we're going to move to the code. We're going to move to doing things with these images in just a minute. Okay, so what I want you to be able to do is to be able to say my dictionary.color component is great job, Colorado. That's great. And color component is there. You can get that. And so then if you want to get bread, you can now understand intellectually, how do I get it on there? I would say, I suppose you could try it in the chat if you're motivated to do that, but I would copy and paste the text, and I would then move back with my cursor, and I would say food, F-O-O-D. Then I would run it, and that's how we get bread onto the screen. Okay, so you should be able, I think, should be able to do that. If not, we want to know. Please tell us. And now let's try, well, here it says statements should end with a semicolon or else the editor, the interpreter complains. Here it says that, sure. Then it says parameters are used to pass, or sorry, parentheses are used to pass parameters to functions. You can see that already. And just to repeat, that is what is happening here. When we issue this command, this string will print in the console tab. What we are asking the computer to do, the interpreter to do, is we're asking it to issue a command. It's a built-in Java command, so it's in purple. Then in order to have a function, sometimes functions take 1 parameter, sometimes 2, maybe 12 parameters, and that's what we do here. We pass 1 parameter inside the parentheses. I wonder if I wanted to try to print 2 different things, I wonder what would happen. Let's say if I print quote, did it work? And if I try to print 2 things, hey, look at that, that's cool. So we can print 2 things. So the print command apparently can take 2 parameters. I didn't know whether that would work or not, but in the spirit of just make a mistake and try it out and move on if it didn't work, that's what I did. And it's fun to try to break things in this way. So now we have print, the string will print, did it work? You can now you're in charge of the print command. I think that's the way to think of it. Now, since we started, if you didn't know JavaScript, what do you know? You know how to make a variable. Think of it as a box. And here, the answer equals 42. We now know that we need to have it say exactly spelled right. We can't halfway spell it correctly, or else the computer will not process that, which is great. Because we want the computer to do exactly what we want and never to guess what it is that we want. So that's a good behavior. Var my variable, we can make a variable that is a string. We can make a list. A list is delineated by these brackets. We can access it's an ordered list, so we can put in a number in this spot. A dictionary doesn't have an inherent order. It's like a bag, maybe. A list, I think of, is a set of boxes on the floor, and they go from left to right. That's, for me, what a list is. It's a set of boxes that sit on the floor. And a dictionary is a bag. I can pull things out of the bag, and there's a name on it, and I can open it up. That's what we're seeing here. If I pull something out of the bag, it says food component on it, like a little ball. I open the ball, and it says bread. Could be we put something else inside the ball and then put that ball back into the bag. That kind of thing is the way that it works for me to envision how these parts work. Is it possible to print it in alphabetical order? Maybe to print the color component and the food component and the number component? I bet. I don't really know how to do that. So I think someone had asked how to maybe reorder the color component. It's doable. Almost definitely you could look up online, sort list items in JavaScript, and someone on Earth has done that before and typed it into a page on the internet, so it's findable. I don't really know how to do that either for the color component or for the list. Let's go to this extremely important part, and with this power, you unlock everything about programming. To me, it is a function. It's a user-defined function. So I will hit this. I'll paste in the stuff on the left that says my hello function, and the syntax, the way that that is said, sort of the language for that looks like this. It says var, because a function, I guess, is stored as a variable. It's like a box that can do steps. Var, then the name, and then an equal sign, then the word function, then a left parenthesis, then the name of the variable, and a right parenthesis, then the bracket, then a return. It says return hello plus string, and then with an exclamation mark. So what happens, let me urge you to do that and then print that and see if you can get it to write hello world in this way on the screen without really typing hello world next to each other, I guess. So what I want to urge you to do is to try to do that. Oh, look at that, Rylan, very cool. So print my hello function world. If you can do that and you get hello world on the screen, say, if you would please, just write yes in the chat to see whether we're all sort of moving together at the right speed. Wonderful. Oh my gosh, it's so fun. Great. Okay, great. So listen to what we'll do next. I want to get, I'm going to say, hello, Makameoni, with a function. I'm going to try to do that. I'm going to copy this. I will paste it here. I will look over here. And I will do that. And I bet that will write that onto the screen. So if you can see my screen, you can see that we now can call this function taking any parameter that we want. That's really the power of functions. That's the goal. Okay, so let me see if you can figure that part out. Let me ask you to give that a try. Okay. So, okay, so if you can get that, type perhaps yes in the chat there, if you would. Seems like people are in good shape in terms of understanding it. Let's imagine that instead of the word hello, you wanted to write the idea of hello in a different language. So I believe, whoops, I think I made a mistake there. Hang on. I wanted to get, somebody said Yadra Vinaka. That's what I want to say, not hello, but every time I call this function, I want it to say a different thing again and again and again. So I will try to change it inside the function. And now it should say that same thing 2 times. So let me ask you to try to do that. See if you can get it to say either hello or some other version of hello, but a different word inside that function, so that when you call that function, it behaves differently. That's what I want to encourage you to try to do. Now, if you can do that, that's really good programming. So let's see if you can get there for that part. And if you can get it to say a different thing inside the function, that's great success, number 1. And then maybe if you could say yes in the chat, number 2, that would be great. Ha, that's wonderful. Okay, great. So that is the power of, to me, this is what programming can do. It can allow me to do the same thing again and again and again and again without having to write the specific thing every time. If we go like this and I paste a bunch of times and I grab people's names and type them in here. I'm just trying to type real quickly, whichever names I see quickly. C-H-R-I-S, and then Mohammed here, M-O-H-A-M-M-E-D. And so what it is allowing me to do, now I'm going to say run. Now we have 6 or 8 or maybe, yeah, 5 or 6 of that function has been called, but I only had to change the greeting 1 time. So if I needed to do it 1,000 times, but then I decided I wanted to change the language of hello into a different language, I want to change it only in 1 place and not in 1,000 places. Even here, I don't want to have to change Yadra Vinaka to a different word. If I need to change it, I would love to change it just 1 time, even for a list of 5. It's more efficient and it will be more insulated to mistakes. It's more reliable to do it this way That's why functions got invented. So now I want to move down to section 2. All right, we'll move down to section 2 and start using these tools in Earth Engine. Okay, so you see section 2, part 1 says clear the script by selecting clear script. From the reset button, I don't know where that is, over here, click reset. Right next to the apps button, which we'll talk about again, we're going to say clear script. That gives me just a blank page, which is great. Now, what we will do is search up here in the top. Okay, see up at the top where it says search places and data sets. They are asking us to type the word elevation, E-L-E-V-A-T-I. I do that and it gives a list. I believe it is, which one? SRTM version 4. For me, it's right here. It's the 5th one. And then click on it. If you click import, it will do the thing we need to do. But if you clicked on the name, it gives you this. This is an overview of that data set. It is the elevation data set produced by the radar thing that was on the space shuttle, I guess in the year 2000, maybe. If we say import, it brings it in. Now they then also ask us to change, you see this says IMAGE, they ask us to change the name of that variable to something else. So I'll change it to SRTM, that's what they're asking us to change it to. Well, I know we can print a number, I know we can print a string. Let's see what happens if we print an image. If I say print SRTM, but, oh yeah, right. You need to do the parentheses in this language, print SRTM. It gives us some information. Let's see what it gives us. It gives us information about what the bands are, what they're called, what the different properties are. That involves when it was taken for Landsat and Sentinel images. It gives us the time stamp of the information, and then a lot of other things as well, like the estimated cloud coverage as well. But here, this is a sort of derived data set. It's not a photograph, it's a derived data set. Now we're going to put something on the screen and you will be on your way to being an Earth Engine expert. So let's try it. Actually, first it's going to look terrible, then it will look good. So we're going to try map.addLayer SRTM. I'm going to make that line 2 or 3 or 4, paste it in there, and then I will put it in here. All right, so Rylan, if you see Chris there in the, oh, Chris, when you write to Rylan or me so that they can see it. I happen to see Rylan. If you could help Chris out, that will be helpful. We'll get you right back on track. That's good. So for those of you who are looking around, I know that the Pacific Islands are relatively very flat. Let's go to this place that's very, very lots of elevation change in the mountains, big mountains. I can see, you might be able to see, if you zoom in, you can see it looks a little bit like there's something there, but the color is terrible. If you've used GIS, you know that maybe what's happening here is we need to change the range of colors that are being drawn. And that's what we do with step 7 in section 2. So now I will take step 7, section 2, and paste that in there. Now I'm going to run that, and that will now show me this image with some more quality, I guess. So if you can do that, let me ask you to say yes in the chat if you were able to do that part. Okay, great. And if you have a syntax error, that's great, not a problem. In fact, that's great that you mentioned it, because it reminds me to ask you, the ending script for all of these is right here. So what do? You click on it. I guess I click once, I click the copy, then I could paste it right here into the browser. Let's see what happens if we do that. If I do that, it gives me SRTM like they asked, and it gives me the 0 to 3000 like they asked. So that's great. It's a nice tool for mailing it, for sending something back and forth to other people if you want. In a way, they mailed us or sent us this message from the past to right now, saying if you want to reproduce this script, you just enter this code and we will run. We have a script, we've stored it. Google stores all of the versions of all of the scripts. And so that's what it is. If you want to store it, your results, and send it to someone else, you go up here to where it says get link. That is my view of this link. And then I say this, now it's on my clipboard, then I can go to my email and mail it to someone if I want to. Okay, so back on the topic of viewing, if you are able to view it, I think some people said that they were okay with viewing it and viewing this in an interesting location. If you can do that, that's great. If you're stuck, let us know. Now we will go to the next step. We'll go to step 3. Section 3 says, I want to do something to an image. I want to, here we will test whether an area is above a certain level. All right, so I will do that. I'm just going to grab that blue stuff that is there in section 3 and paste it in. And I will say high areas are where they are above 2000. Map.add layer, high, above 2000 meters, and that's what shows in that spot. So if we were to move over, we don't see very much that is white, although there's a little bit over here in Papua New Guinea. We can see there's some very, very high mountains there. Most of the rest is not in that approximate area. If we go into the Solomon Islands, and we now could use this to show you the inspector. All right, the inspector, you've been here in the console, that's what the print does. If you go to the inspector, that allows us to look at just one pixel. So I will go here to Gold Ridge and click there. And here it says I have 10 meter information. Here, I'll turn this on. It's still black. There's not a lot of relief compared to the whole Earth. On the Earth scale, there's not much. But how would we change that if we wanted to know areas that are above 200 meters, let's say? I could type 200 in this spot, then run the program. Then it will show areas that are above 200 meters in the Solomon Islands. I can control here let me turn off this layer. Here I can then turn on and off the transparency to see what area they're referring to for 200 meters. So if you could, see if you can get this number to be different and drawing differently so that we can know that you're kind of controlling that part. Okay, and once you can do that, go ahead and type yes, and I will be right there in 1 second. Okay, great.
Hi, Jeff.
Okay, yes.
This is Maria.
Oh, hi, Maria. How are you?
Very well, thank you. I heard you needed something. Do you need the meeting ID for some people that dropped out?
I don't think so. At least that somebody could be asking, but I don't think I know what we're talking about right now.
Maria, I was the one who texted Sylvia. Sorry.
Oh, okay. Sorry. I'm sorry. to interrupt.
Somebody needed a meeting ID. They weren't allowed to get back. And then another person was denied access.
I don't know what that's about, but let me get you the meeting ID and I'll put it in the chat. Okay.
Okay, great. Thank you.
Hold on a second.
Okay, no problem.
Sorry.
Okay.
Sorry, Jeff. I didn't even know we needed a meeting ID. No one else seemed to need one.
No problem at all. So if you are at this spot, just to refresh, this is where we want to be. We want to be in section 3, part 2. Now I'm going to move to section 3, part 3. I'm going to calculate the slope of the shuttle data, of the elevation data. I'm going to calculate the slope by pasting in this a call to this pre-made function called ee.terrain.slope. All right, so I will paste that guy in there. And let's see if we can do this. Here's the slope. Now, if we're zoomed far out, it's a strange color or strange texture. But when we zoom in further, you can see that there is a lot of texture inside the shuttle imagery. Okay, so see if you can do that and let us know. Great. Okay, excellent. This is great. Perfect. So what we will now do is we're going to put in this last little bit, and then we'll stop and we'll rehearse or review what it is that we have going on right now. So I'm going to paste in this last little part. Maybe I'll even get the final script because my scripts tend to get very messy. I'll just get it over here and paste it in and run that script. And this is what they think we should have more or less inside this space. And here we have the slope, and there it is. Okay, so if you can get to this point, let's think about what you have happening now, what you're able to do now. What we are doing, let's maybe work backwards from the bottom. We have, maybe that's too confusing. We'll go with this, SRTM. What is that? That is a layer that we have found in Earth Engine's catalog, like Ryland showed. This is one of the items inside the catalog. Now we are manipulating it using the API, the programming interface. That's what's here. We are manipulating it here, where we say, I want true or false. Tell me for every pixel, white or black, is it above this value, 2000? And if so, please put it there and call it high. Could be called any variable name. And we could then draw that onto the screen. That's why it appears on the screen. And that says above 2000 meters. We can then make a new variable, which is, the variable actually is an image. And that is ee.terrain.slope is the name of the programming call produced by Google for us, so it's in purple. SRTM also is a reserved, sort of a special reserved space up here for information that's inside, directly inside their data set, their catalog. Then we save it as a variable, and there it is. It's inside a box, but the box contains an image that is as big as the whole world. But conceptually, it's a box with one thing in it. That box is an image. We can look at what's inside the box using map.addLayer. We also could look at what's in the box by saying print. I remember we did that at the beginning. Print slope. And also, if we want, we can print two things. We did slope, and then we could say, this is the slope layer. We had established before that we could print with two parameters, and there is the image itself that's being printed, and then the text to help us to recognize what it is. This is the slope layer. Okay, now if you can get to that spot, that is also pretty good. We are applying a computation to an image. Now we will go to section 4, which is applying a spatial reducer. We have about 40 or so minutes remaining in our time. We've already gone 2.5 hours almost. And so that's about how much time we have left for this round of today. We're going to go through section 4, section 5, and section 6. And then I will probably stop before section 7 and allow you to run on at your own whatever speed you want, and then we'll answer questions as we go. So I'm coming now back to section 4. Section 4 says apply a spatial reducer. What does that mean? That means if we want to estimate or calculate what's the average elevation in a particular box of a certain size. What is the average elevation? How would we do that? If we did it in ArcGIS, you would download it, you would maybe draw or somehow get a shapefile. You would then intersect those two, you would do summarize by zone, those kinds of things. You would get a table, you would open the table. That's approximately the method we would use for ArcGIS. Here, it's the same idea, not necessarily better, but it's short and pretty efficient. So we will do that. So here they say print the mean value. I want to actually just kind of get rid of this code. I don't need to see all of that. And so let's put it back in. So SRTM reduce region. Oh, I tried to just paste it without thinking about what was happening. That's okay too. But the message is, it says geometry is not defined. What are they talking about? They're saying, oh, right, draw a triangle. I wasn't even reading anymore. So they're asking us to draw a triangle over whatever area we care about. Or I'll draw a rectangle. I don't want to be told to draw a triangle. I'm going to draw a rectangle. It comes by default as being called a variable called geometry. And so that's the area. Now, if I hit run, it will say, oh, I know what geometry is, sure. Then I can do a function called reduce region and give an answer back. The answer can then be printed onto the screen. Now, if you can do that, please write okay in the chat. Let's see if that is also a doable thing with this short amount of training. Great. Alicia is always first with the okay. Well done. Now, is anybody else able to get that onto the screen? Okay, so as you do, let's look at what's in there. All right. Oh, Chris, you're back up to speed. That's great. Thanks, Rylan. Very good, everybody. Now we are, this is one thing that's tough about doing it on Zoom compared to in person. What I want to do, really, is to have us all in the same room. Then when, let's say Chris had his hand up a few minutes ago, when he's stuck, I notice somebody is sitting next to him and they're not stuck. So then we can say, can you please help him out there? Because you're almost definitely at the same spot. So then you can help each other figure it out. We can't do that here because it's on Zoom. So you can't just ask the people who are nearby, except for a few of you who are all in the same office. But that's something we'll get to do in person again sometime soon, I hope. So here we are, mean elevation. What is the mean elevation in my place that I drew? It's here, 1,766. For sure, whatever you did, it's different. It's a different average elevation. When we say mean average elevation, the scale of the, the scale of the pixels that it uses to summarize, that's the size that it uses. And let's see, what size of area have we summarized over? Oh, right, I'm all the way over here. I'm going to go, over here. Let's go over here. Sometimes you'll notice that you have a bunch of layers and you might want to turn them off. I want to turn off this one and I want to turn off that one. so that I can learn where it is that I am by looking over at the sort of Google Maps view. So when I do that, and when they're both on, sometimes in my script that I was looking at this morning, we have 17 layers, and I don't want to push that button 17 times. What you can do is you can push, when I'm hovered over here with the layer, you push a 0 and they all go off. When I push a 1, the first one turns on. When I push a 2, the second one turns on and off. When I push a 3, nothing happens. But it's kind of nice sometimes to push on the 1, and 1 goes on and off, independent of 2 going on and off. So it's a pretty neat function. So let's try to change the thing that I draw, or the place I want to summarize. I want to summarize over all of the Solomon Islands and see what is the average elevation, maybe for some subset of it. So I will do new layer, and then I will go over here to this gear, and I will say here, whoop, now I'll click on it, and I'll say SOLOMONS with a capital. And then instead of doing reduce region over geometry, I will do reduce region over Solomon. And I will also remember that the map.add layer also was for this other variable called geometry, but I want to say SOLOMON. Now I noticed that I've had to type Solomon twice, which is dangerous because I typed it wrong one of the times. I know that I'm supposed to type an S, but suppose I had forgotten. What I might do here instead is to say var my study area equals SOLOMONS. Now it turns into purple. Now, instead of hard coding the word Solomons again and again and forgetting and making a mistake like this, we use that same kind of idea that we did when we were making a function, which is I want to refer to things as few times as possible, because then you don't make so many mistakes. We always make mistakes, and it's fine, but it's nice to have a few mistakes and then solve them and feel proud instead of having 100 mistakes and being just confused. So here, now we are summarizing over the Solomons. Now the problem was I didn't draw any rectangle for the Solomons. So let's do that. I'll do it here. Now it might seem like I'm a little bit off track here, but what I want you to see is several things. I want you to see that now inside I have a different number. It said 1766 before, and now it says 766. That's a really strange coincidence. But it's a coincidence because they're in entirely different areas. But that is the average elevation inside the box that I drew. Now we knew that some of this was over 2,000 meters, I think, or maybe it was 200 meters. But 766 seems reasonable, and it is actually, that is working correctly. So if you could create, it seems like those of you who typed yes were able to, if I remember right, draw a polygon on the screen and issue the reduce region command to do it. Is that true? I forget what I asked yes for. If you could type yes again or okay, if you've been able to do this reduce region, that would be helpful. Okay, so we have a couple people have gotten it, 3 or 4, the group, some in the group, I think that's the group, got it. Now, if you're stuck, this is the moment. We want to get you unstuck. In case you're stuck, let's think about what we're doing. okay? Trying to build from what you know, okay? Now what I'm gonna do, if you can just, don't worry about pasting anything. I wanna just give you a little tour for 3 or 4 minutes, okay? So Rylan, I see another brave and excellent call for help. Thank you again, Chris, that's great. And now what I want to do is I want you to see this reduce region call. What is it? Well, there's this tab here called Docs, all right? If I click on Docs, I can see reduce region, that's in purple. Everything that's in purple, unless it's like the word print, but everything that's in purple is here in the Docs. Here's reduce region. Reduce regions in plural is for another day, but that's like summarized by zones for those of you who use ArcGIS when you have multiple zones. But here for reduce region, let's look and see what it does. It says it applies something to all of the pixels inside a rectangle or a triangle or for a bunch of points. Let's look and see. It takes a bunch of parameters. The parameters are here. There's a maximum number of pixels. It probably would not give us the average elevation of the whole Earth because that would probably, well, Google helps us to not do that. Unless we really want to, then we can override that parameter by saying max pixels equals 1 billion or 1 trillion. And then they will do their best to do that. So what does it return? You can see the word dictionary. It says it returns a dictionary. Well, okay, we've heard about a dictionary. Let's see if this thing that gets returned looks like a dictionary. It returns this thing called DICT. That's here, I think. I'll run it, here I'll hit run. Oh yeah, it said for a second there, it's a dictionary. It's a dictionary that contains one component, and the component is called the elevation component. So probably we could say DICT dot elevation, just like we said, whatever it was called, dot food component. We could say so-and-so dot this component and get that number. That is helpful when maybe we have a function and we want to return 100 things back from the function or 6 things back from the function. Okay, so now we are here with applying a spatial reducer. Now what we will do is load and filter an image collection. And I want to show you that that is also possible. What that does is we're going to call the thing called filter date. I want to now move quickly enough that I would like to just go and go get this text and run this script. I'll just put it, sorry, up in here. So what does that do? That zooms in, they zoomed us to a certain place. But here, then we do map.add layer, filtered. Oh yeah, there we go. So occasionally you'll see many layers, but I only asked for one. That's because I got impatient and I hit run 4 times while it was still working on the first one. So I'm going to hit run just 1 time. Now I have just the one thing in there. Here in this case, Earth Engine works 4 times harder than we usually expect if we're not patient. But here you can see now this shows the messiness of Landsat data, of real individual images. These are images taken in the winter period in 2016 in an area that gets some snow, but is pretty cold at this time. But more than that, it's cloudy at this time, and that's what we see. We can see that if we played with the bands, we might be able to see some of the stuff under here. If I wanted to do print of filtered, just to learn what is inside here, it's a whole collection of images. Maybe you see that word collection and you remember that that Rylan said there are 2 different forms of rasters. There's an image, which is an individual one, and a collection, which is like a stack of images. If you think of a stack of books on your wall, This is a stack of images. So here it's saying, hey, you asked me to print 5,000 images. I can do an average if you want of 5,000 images, but printing their names to the screen, you probably don't really want me to print 5,000 names of images onto the screen. So they sort of caution us or prevent us from doing that. It's possible to get that list. You can do it if you search online. You could say, print a list of all of the images in my image collection in Earth Engine, and for sure someone has done that. But we're not going to do that now. We just want to look at the fact that we can do map.addLayer of filtered. What that does is it shows the top one. Actually, that's what we see on the screen. So let's now go to playing with image bands. This is section 6. This is the last section I'll do with you side by side. So here we are doing this, I don't know, I'm gonna get this set where it says filtered, filter date, make it red. We'll do that. Oh, L8 is not defined. What does that mean? Maybe you see little capital L8, but over here I have little L8. So now if I run that, probably it will run, not sure. But if I get stuck, I'm going to go down to the end and grab this code here, paste it up here, and put it in. That will hold together without any bugs because it was sort of recorded at the moment that Nicholas Clinton, who did this, I think it's his, that he recorded it by saying get link. So here there's a little L and a little L, and some other one was a little L, something like that. So it works, and that's what's now being shown. Here on the right is a relatively clear day at the top of that giant stack of more than 5,000 images. Here in this path and row, it was a cloudy day on the top piece of that giant stack of images. We didn't look at all for getting rid of clouds. If we could, if we want to, those are also things that we can filter. So if you're able to follow this, even if you're not following along with me typing it, what I want to do is show you, I think I'll just kind of finish this part by showing you one of our scripts. Let's see if I can find the script that I worked on this morning. It is here in 2901. It's this thing, bulk Z, 2021. I'm in stage U of the development of the script. Here we are at number 72. Okay, so hoping you can still see where I am. You're not going to need to type anything more here, but so if you could just type okay, if you can see where I am here with this script, this thing running, you can just type that. Okay, great. So this is a program that I wrote to run over a large area. It uses exactly the things that you have learned about so far. Let's look. Here is a function right here. I need to do some comparisons of some images. I wrote a function called which bin am I in? It's for understanding how extreme values are for each other. Just like you, var, name of the function, equal sign, function, left parenthesis. Here I take in 3 parameters, an image, I don't know, oh, it's a list, and then another list. Then I make a variable, and I have a variable name. Then here's that GT that you saw when you did it. GT, I want to know, is this thing bigger than each of those numbers in the array? Then there's an AND clause where I say if they're both true, I want it to be true. This is on every pixel. Then at the bottom, here's the return. I want to return this. Well, who calls this function? I can go search for it, and here it is. Here's a call to a function, just like you made a call to a function called myHelloFunction. I'm making a call to a function called which bin. That function, it turns out, is inside another function. which is mentally complicated, but it's no different in terms of the structure. If we go down a little further, here we can see here are some if statements, just like you've seen. Here's a variable. This is a string. A string is called L8. Here's a string, it's another thing. Here's another string where we filter out the land cover. I can run it just like you can run your scripts. And that is what a program is. It's a series of many, many, many statements that are extremely carefully organized to achieve a result. And that, for at least this part, is what I want to leave you with. That what we're teaching you, you might say, when you go home, you might think, all we did was print, we looked at some things on a screen, I don't really feel like I learned anything. Well, you learned the basics of exactly what I'm doing in this giant script that, that I wrote. Here's map.addLayer. Here is, okay, we'll change those privileges there in a second. Rylan was asking me about that. But sorry, here's map.addLayer, just like you've seen. It takes default study area, it takes a bunch of parameters. It prints something onto the screen over here in the set of layers. Here's a dictionary, you know what a dictionary is. Here's a call to a function, it gets run. Here's a print statement. Here's a call to a function. Now this function is like 1,000 lines long. Not because it's really any different than what you've done, just because it's doing more things than what you've done. It builds on exactly the same things that you've learned about so far, which is you have learned about lists and dictionaries, ordered items, variables, things that are in blue, there's things that are in purple. Here's the word ee.dictionary. You can learn what that is just as well. Here's map.addLayer. All of those parts are the same thing, using the same structure and same idea as what you're doing. All of them are a lot of what you see in my giant script, you have already done. Playing around with image bands, getting something onto the screen, sending in particular parameters, writing something as the name of it over here. You want it maybe to say RGB, you can do that. And those are the parts. So now what we're gonna do, we have 15 more minutes for the session today. What I wanna ask you to do is several things. It's the morning for you. I want to ask you to go from here and go all the way down to the end of section 16, I think it is. 15. I want to urge you to go to the end of section 15. Really, it's the end of 14 is the end of the things that you do. All it is doing is things that you have already done. It is, well, there's a few new things. It's building a composite with a particular tool that they've given to us, but also doing a function. Then there's a more advanced thing of mapping a function over a collection. And so Makamioni is nearly dead, it looks like, killed by this programming tutorial, but he's back. That's great. So here it is, write a function. That's something that you know how to do. You wrote a function called myHelloFunction. This is just the same thing. It's just doing it for Earth Engine type of images to work on. Okay, so that's what we're going to do. I will stop right now and encourage you to start right where we stopped, which was right here in section 5, 6, and 7. I went quickly from 5 to 6 and stop there. I would suggest to go back to 5, learn that, learn 6, learn 7, and then go all the way through 14 for Wednesday, okay? It will take you, if you do it now, it'll take you 20 minutes. I think I would advise to do it now if you have time. Stand up and stretch your legs and come back and follow along, and then you will be ready to go on Wednesday. For the next 13 minutes, we will stay here with you. And so that is what we are going to do. We'll wait for you. And if you have any questions, please feel free to ask them.
Thank you, Jeff.